So some reactions are irreversible reactions. The irreversible reactions can come only in one direction. So if you have a reaction between carbon and oxygen to form carbon dioxide, there is no way that the carbon dioxide is going to go back into carbon and oxygen. That's why we draw the arrow from the left to the right, and that's it. The carbon dioxide gas cannot be changed back into carbon, solid, and oxygen gas. No way what you have done. While the opposite is a reversible reaction in which the reaction can happen in both directions. So, for example, the nitrogen can react with hydrogen to form ammonia. This is a product from their reaction, and if you want to balance, this is 2 and this is 3. The reversible reaction, the nitrogen and hydrogen can react to form the ammonia. The ammonia can be broken down back and form the hydrogen and the nitrogen again. After the reaction has proceeded to the forward, it will proceed backward also. We can always represent this equilibrium reaction by a two-way arrows. The equilibrium is the irreversible reaction where the forward reaction rate is equal to the backward reaction rate. So there are three options in the reversible reaction. Either the forward is faster than the backward, so the backward is slow rate and the forward is a fast rate. Or the second option, if the forward reaction is slower than the backward reaction, and the third rate is the forward is equal to the backward, and we call this the equilibrium. This is the only case that I call it the equilibrium, in which the forward reaction rate is equal to the backward reaction rate. But what is the effect of changing the reaction conditions? The effect of changing the reaction conditions on the equilibrium. Changing the reaction conditions like concentration, like the temperature of the reaction and the pressure of the container where the reaction is happening, can change the equilibrium position. So instead of the reaction happening in equilibrium and the rate of the forward is equal to the rate of the backward, changing these concentrations, like increasing or decreasing one of the concentrations, or increasing or decreasing temperature, or increasing or decreasing pressure, can lead to change in the equilibrium position. The effect of changing the temperature. Before you have to know the effect of changing the temperature on the equilibrium, you need to recognize is my reaction endothermic or exothermic? Is my forward reaction or is my reaction is endothermic or exothermic? We can know the reaction to be forward or exothermic by either memorizing some of the reactions. So some of the reactions we memorize that they are exo or endo. For example, we know that melting is endothermic. We know that neutralization reactions are all exothermic reactions. We know that freezing is an exothermic reaction. The second way is that he can tell us, so he will tell us some of the reactions are exothermic. He will tell us this hyper process and this process is exothermic, so he will tell us. The third way is that he will give us some values, so he will tell us that the delta H of the reaction is negative. I will know that it is exothermic. If you tell us that delta H is positive, so I know that it is an endothermic reaction. This is ways that I will know if my reaction is endothermic or exothermic. So before doing anything, knowing that you have to know if the reaction is exothermic or endothermic reaction. Then you see what is the effect that you have done. You have always to differentiate between what did you do, what is the effect done, and what is the response between the systems. This is two different things. Don't confuse what did you do with the response of the system. So if you increase the temperature, the system will try to decrease the temperature. According to low Chatelier principle, it tells us low Chatelier principle, according to the scientists who discovered the principle, telling us whatever effect you do on a system which is already on equilibrium, the system will try to do an opposite effect. So if you increase the temperature, it will decrease it. If you decrease the temperature, it will increase the temperature, and so on. So what happens when the system decreases the temperature? It will try to go to a direction which decreases the temperature. But what effect decreases the temperature? We know that exothermic reactions means that the temperature increases. So whenever you want to increase the temperature, the system will go towards the exothermic direction. While if it wants to decrease the temperature, it will go towards the endothermic direction. So again, I have increased, the system decreases, it will go towards the endothermic direction. And you have already decided from the beginning which one is endo and which one is exo. He will tell us. If the forward is exo, then the backward is endo, or if the forward is endo, then you will just go to the forward direction. Then what happens when you decrease the temperature? The system will try to increase the temperature. Increasing the temperature happens by going towards the exothermic direction, and you already have decided from the beginning which one is exo and which one is endo. What about changing pressure? If you change the pressure before changing the pressure, the same way before changing the temperature, you decided what is the directions. Also, when you change the pressure, look at the reaction. For example, in the previous reaction, which is 2H, 3H2, 3H2 plus 2NH3 plus NH3 to form 2N, sorry, 3H2 plus N2 to give 2NH3. Here, how many moles do I have? I have 4 moles in the reactant. 3 moles and 1 mole is 4 moles. How many moles do you have here? I have 2 moles. Which direction has higher pressure and which direction has lower pressure? This one has high pressure and this one has low pressure. So if you want to increase the pressure, the system will try to decrease, so it will move to less moles, so it will move forward, because forward there is only 2 moles. If you decrease the pressure, the system will try to increase the pressure, so it will move towards more moles. Where is more moles? More moles is the backward direction. What about concentrations? Increasing the concentration of any of the reactants, the system tries to decrease these concentrations. So they will try to move away from them. So they shift towards more products. Why they shift towards products? Because the system tries to decrease these reactants. So they move away from the direction that one said. So if you are increasing the concentration of reactants, then the system will try to increase the concentration of products. While if you increase the concentration of products, the system will try to decrease them, so it will move towards backward and increase the concentration of reactants using catalysts. In the rate of the reaction and the effect of the changing the rate of the reaction by a catalyst, we know that the reaction rate increases when you add a catalyst. But look here, there are 2 directions. You are increasing the forward direction and you are increasing the backward direction. It's like you are having the person who is making the hole. If you remember the example, one person is making a hole and one person is closing the hole. So if you give Red Bull and make this person faster and make this person faster also, so the hole will not change. Why? Because you have increased the digging speed and you have increased the filling speed of this one also. So again, these 2 guys, one of them is making a hole. He is the forward direction. So the hole keeps getting bigger and bigger and bigger. The other guy is the backward direction. He's trying to close the hole. So if you make him faster, if you give him Red Bull drink, he will start closing the hole, closing the hole, and the hole will get smaller. So if you give Red Bull to this guy only, he will be very fast. You give him a catalyst. But if you give Red Bull to this guy also, he will be also fast. So if you give catalyst to both reactions, forward and backward, what is the net result? The net result is nothing. The net result is nothing. So the only effect is that, memorize this part for me, the equilibrium is reached faster. The equilibrium is reached faster. The equilibrium is reached faster. But it does not shift the position of the equilibrium. So it doesn't move forward more or backward more. It will be still in the same effect, in the same equilibrium.